Hello Bulldogs, here's a short video on how to put a number into scientific notation. Scientific notation is a method of writing a number that's very large or very small, and it makes it a little bit simpler. It simplifies it a little bit. That's what most people use it for. The true reason for scientific notation, though, is to show significant digits when you have many zeros, even in the measurement. Okay. Here's a couple rules for you. Number one, must be equal to or pretty close to, if you have to round, to the original number. So you have this really large number. Your answer in scientific notation should be the same numeric value. Maybe a little bit of change because of rounding, but at least very close to it. Okay. Second rule is what you do is you take this large number or the small number and you move the decimal so that it makes the number between 1 and 10. Okay, it can actually be equal to 1. So let's say it can be, whatever the number is, we'll say n is the number, it must be greater than or equal to 1, okay, and has to be less than 10. Meaning it can be 1.0 for a very long time, or it can be 9.9999 for a very long time. It has to be equal to or greater than 1, less than 10. Okay. The third rule here is that you take this number and you multiply it by 10 to some exponent. Okay, it's always going to have times 10, and there's always going to be a power up here. Okay, and then of course it has to have the correct number of significant digits. Alrighty. So here's some examples. There's a very large number, lots of zeros. Of course, significant digit rules. This has 4 significant digits because there's no decimal at the end here. Written at the end. Okay, and so what we do is we take this number, make it between 1 and 10. So we don't want to put it here because that would be 0.98. That'd be less than 1, right? We don't want to put it here because we have 98, so it's greater than 10. Right? So we want to take the decimal and move it between the first 2 whole numbers. Okay, so I'm going to rewrite this. So we get a 9.8, okay, 03. So we're making all those digits that are there insignificant, writing all those out. Okay, and then remember the third rule is times 10 to some power. And so what I want to think about is how many times do I have to multiply 9.803 times 10 to have this many zeros. Okay, and so what we do is we here's where the decimal point would be, right? And so we have to count how many spaces there are. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Moving it 16 places. Okay, so I'm going to put multiply by 10 16 times. And so you can think about how would I make this number equal to this original number, right? So it has to be equal to this original number. Okay, and I would do that by every time you multiply by 10, it moves the decimal 1 place. Okay, and so I'm multiplying it by 16 times, making these numbers equal. So that's for large numbers. Okay, large numbers always have a positive exponent. Okay, and here's a really small number. Lots of zeros before, 0.0, so less than, so we want to move the decimal so that it is between 1 and 10. Okay, so we don't want to move it here because that's 0.9, less than 1. We want to move it between the first 2 whole numbers, 0.98. Okay, so then we can rewrite this. 9.803, right? Trailing zeros are significant if there's a decimal, so that 0 at the end is actually significant. Okay, so here's our number between less than 10. So I multiply this by 10 to some exponent, okay? But now, if you think about this, what we want to do to move the decimal from between the 9 and the 8 this direction is we want to divide by 10, really, okay? We'll write it like this, but if you think about this, what we're actually doing is we want to, every time you divide by 10, the number is going to move, the decimal is going to move to the left. So you can think about this, what we're actually doing is we're doing 9.8030 divided by 10, how many times? And we count how many times we have to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are dividing by 10 12 times is a way to think about it. Okay, 10 to the 12th power. Okay, but we don't really like fractions, so we don't write it this way. We write it as a multiplication. But when you divide by something. Another way to think about that is a negative exponent. And so we write this as a negative exponent to make these two equal. Okay, this negative exponent means you're dividing by 10 that many times. Okay. So there's a couple of examples for you. One large number, one small number. Now, of course, try some on your own. And just remember, these two numbers at the end, your answer should be equal. They should be the same. Okay, same value. Okay, we divide by 10 12 times, that would make this number equal to this. It's a good way to check yourself. You always check your answer to the original, double check it, make sure you got it correct. Okay, thanks for tuning in, and we'll see you next time. Have a wonderful day.